Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, we're going to prepare ourselves for plotting bivariate by creating new variables. Some of the variables that I'm going to create in this video I will be using for plotting in the next videos. So I'm going to jump down to the timetable, and I know that these functions are in the outline file. So I'm going to go to RStudio, open up our Markdown file from last time, and because it's a new day, I'm going to save it as today's date, and compile it by clicking knit, making sure that we're starting with a file that works and has a new file name so that if we screw anything up, we know that it was something that we did today. Let's open this in our browser, and in our data management section, we have a section for creating new variables. And there's lots of different things we can do to create new variables. We can go from a categorical variable to numeric. We can use numeric variables to create new numeric variables. We can start with a numeric variable and create a categorical variable. Also, there's sometimes when you've got a categorical variable that just has lots of categories. I know that either, I think race is, a person's race is one of the categories in NESARC that has like 30 or 40 categories. Or maybe it's like country of origin. That's another one that has like 50. So you might want to condense, like say, all the European countries to Europe, or all the African countries to Africa, or something like that. There are situations where you might want to work with dates. For example, if you wanted to know how old someone was very accurately to when they answered, rather than saying they were 24 years old, you might take the interview date and subtract off their birth date, and that range would give you the number of days they were old, and then divide that by 365 and a quarter to get how old they are in years. And then you could have fractional years for an age. So maybe that 24-year-old is actually 23.79 years old. Okay, so this is what we're going to focus on today. I'm going to jump down. Well, it doesn't make much sense. Anyway, here's some empty headings for us to put our new variables in. All right, let's go back to the website and scroll up to the previous year's assignments and look at this RMD, or this HTML file, to get some examples of how we can create new variables with the ones that we've chosen. All right. So in the data management section of last year's assignment, I have a creating new variables section here. I'm going to click on it to jump down there. All right, the variables that I'm going to create in this video are going to, let's see, well, I guess this will be clear when, let's not worry too much about this code book. Let's just go through each example. All right, so I have a smoking frequency variable, and let's see, I can do both things. Let's go up to the code book on this window so we can look at the code book and how we're treating this. All right, so I want to know the number of days a person smokes per month. And I have this smoking frequency variable, which if I go over to the code book, interesting, that changes the size every time I go back. Here's smoking frequency. And there are these 6 categories and one more category because anyone with an NA was given another category, which was number 7 for never. So we actually have 7 categories for this variable, and we're going to use those. So yeah, if I were you at this point, I mean, not at this point in this video, but if you were about to do this, I would copy all this from your code book, go down to this section of from categories to numeric, and paste that code book in, because here are the descriptions from the code book that you would have just pasted for doing this conversion from categorical to numeric. All right, so how does this work? If we have a person who is every day, we're going to change that category to be equal to 30 days. Okay, so we're just going to make an assignment that if smoking frequency equals, and notice that this is a double equals because we're doing a Boolean logical comparison, is smoking frequency equal to 1? If that's true, then we're going to assign it a value of 30. Okay, so that's sort of the first step, is to think about what is the numeric value that would correspond to each of these categories. So I have chosen basically to have 4 weeks roughly, but 30 days in a month. Okay, it's not my fault months are like this. If it was up to me, we'd have 13 months with 4 weeks each, and with a little fluff at the very end. Anyway, so that's where we're at. This says 5 to 6 days a week. So here I put 5.5 because that's in between 5 and 6, and multiply that by 4. So if they're in category 2, then this will equal 22 days a month. And then I do that for each one. 3 to 4 days, I do make that 3.5 times 4 weeks. 1 to 2 days, okay, 1.5 times 4 weeks. And then we've got 2 to 3 days per month. So there I'm just putting 2.5. Once a month or less, I'm giving it a 1, and a never is a 0. Now coming back to this code, how does this code work? I'm starting with nisarc underscore sub, that's my data subset, and then, using the pipe, and then I'm going to mutate. The mutate function either creates new variables or can update existing variables. Here I'm going to create a new variable called days smoke, and that's going to equal this function case when. Case when, I love case when because it keeps us from having a bunch of if then else type statements. And so case when, so if it's this case, when smoking frequency equals 1, then days smoked will equal 30. If it's the case when smoking frequency equals 2, then days smoked will equal 4 times 5.5, 22, and so on for all the cases. So case when starts with that open parenthesis and ends with this close parenthesis, and you can see why I put these leading commas. I hope it really makes this very easy to read. The first argument never has a comma, but all the other statements have a comma. You don't have to try to chase down the commas at the end of the lines. All right, so I have now created with this piece of code, well, I'm going to copy and paste this code in a moment, a numeric variable. And so now I have, if I do a summary of days smoke, which is the new numeric variable I just created, there's a minimum of 0. The first quartile is 0. The median is 0. That's because there's a lot of people who never smoked. The mean number of cigarettes smoked for everyone is about 11. The third quartile, which means that, is 30 cigarettes. So that means the first 75% of the data smoke 30 cigarettes or less. And the maximum is 30. Or, excuse me, this is days. 30 days a month. The average number of days it smoked is 11. Excuse me. And then the maximum is 30 because we specified 30 up there. All right, great. So we now have created a numeric variable from a categorical one. I'm going to grab this code and paste it into my current project. So I'm going to go back to RStudio. I'm going to find class 07. Oh no, we're doing new variables. You know what? Oh, creating new variables. Okay, I got lucky. All right, creating new variables. So we're from categories to numeric. That's what we're working on. I'm going to insert a new code chunk with the Control-Alt-I. You can also do code insert chunk, or you can just type these left ticks with the brace R, and I'm going to paste that in here. Okay, for you, of course, you would put your variable name from your codebook here. You would put the new variable you want to create there before the equal sign, and then you put the values that you're using from the categorical variable on the right side of the equal sign, and then the new numeric variables value on the right hand side. Let's see, so let's make sure that this is going to run. I'm going to, have I set the working directory yet? I don't think I have. So because we want to run this code as we go and not just have to knit the document every time. First, we're going to set the working directory to the source file location. That does the set working directory, and that means that we can, R can now see. It hesitates. My computer hesitates a little bit when it's recording videos sometimes. And that's what it's doing right now. Okay. So in the folder or in the directory that we just set, we have the ADA functions.r, which we need, and we have our data set there. Okay, so that's why we need to set the working directory. And then we can run all the code up to this point, and that will make sure that we have everything we need. And I'm going to do that one more time. You don't have to do this. Let me tell you what I'm doing. Before I started recording the video, I had run some code, and so I had some environment variables. I had some variables up here. But I want to make sure that where I'm starting is where the R Markdown file will start when you actually knit it. It's a bit, things can break, of course, if you, anyway. So I'm going to clear my environment. I'm going to click the broom, and I'm going to remove all objects from the environment, and do check this box. I don't know what hidden objects are, but I don't think I want them around. So I'm going to click yes. My environment is empty. Now I can run all the code from the top, and I know that my environment, when it gets to this line of code on line 630, it is exactly as it would be as when I knit the file. Okay, so now I can run this line of code, or this chunk of code, and see what happens. Okay, so it submitted the code here, and here's the summary, and it's exactly what we saw in the HTML file before. Excellent. So this worked. Okay, so we've got now we have a numeric variable that we created from a categorical variable. And the reason for doing a summary at the end, of course, is to make sure that we have something sensible from this variable. Now there are, of course, there's plenty of other things we can do. We are about to do some plotting, but you could also create just a quick histogram. This is something I would do quite commonly if I just want to test something very quickly. Do a quick histogram and say, okay, that's sort of the histogram. So most of the people who smoke every day. There's a few people who smoke intermittently, and there's lots of people who never smoke, or maybe smoke just once a month. So we could add several more. We could add more bins to our histogram, make them narrower. Okay, so what we're seeing is about right. If we make our bins very narrow. All right, so this argument that I'm adding to the histogram function, it says how many bins do you want? And so I was making the bins narrower and narrower to just resolve the difference, say, between 0 and 1. If we go back through them, yeah, you can see that the 0 is this point, this long line here. 1 is that little tick mark by my cursor. If I go back one plot, 0 and 1 were combined in this previous plot. It hardly matters, right? 1 was very infrequently used. Okay, so we successfully created a numeric variable out of a categorical variable. Let's go find another example. So this is a case where we have a nice income variable in NESARC, but in previous years we had this adolescent health database, and they had a income variable that was only categorical. And that's pretty annoying because there's lots of levels of these categories, right? The first one is less than 5,000, second is 5,000 to 10,000, then 10,000 to 15, and 15 to 20, and so on. And you've got like 12 categories here. And wouldn't it be nice if that was just a number? So I did the same thing here. I used a case when, and the income variable that was categorical was called income4. And for each of these levels, I assigned a number, which was sort of just the midpoint, right? So between 10,000 and 15,000, that's 12.5. And created a new variable called income4, because that's the original variable name, underscore numeric. So now I have a numeric version of that variable. In our codebook, if we go to the codebook of the NESARC dataset and look for income, we have a numeric value of their income in dollars. Thank goodness. They also provide a categorical version of that. And so choose which one you want. I think the numeric one makes sense. Category 7 is not as meaningful as 21,243, okay, which I'd get from the numeric one. Anyway, but if we only had this one, then we'd be looking to convert it to numeric. So I wanted to point that out because that is something that comes up fairly commonly. Okay, let's keep scrolling down. All right, let's create a new numeric variable from other numeric variables. So in the NESARC data, we have two variables for height. We have a person's height in feet and height in inches. And this is part of just about data collection. You ask someone, how tall are you? And they say, 5'11", and you've got a field for 5 feet and 11 for the number of inches. So now, as the analyst, those two individual numbers don't do you any good. You really just need their height in inches. So we're going to create that new variable here. We start with the NESARC subset and then create a new variable with mutate. It's going to be called height in inches, and it will equal the height in feet times 12, because there's 12 inches per foot, and add that to their height in inches, and that combination gives you their total height. We look at a summary of that. The shortest person is 4 feet, 48 inches. The tallest person is 84 inches. Is that just too tall? Is that 7 feet? Let's see, 50 is 6, and then 62, and then no, I don't know what I'm doing. You can use R as a calculator. 84. Sorry, guys. I'm not good at this. It is 7 feet. Okay. I should have said confidently the first time. And then a mean height here is 66 inches. So 5'6". Oh, that's where I made a mistake. 60 inches is 5 feet. Okay. So let's go create that variable. You want to create this variable for your data set anyway. Just go ahead and copy and paste this into yours. So we're going to go find RStudio. This is a numeric variable to a numeric variable. So it's under this section here. And I'll create a new code chunk, Control-Alt-I, paste it in there, and we can run it. Nice, we get the same result. Now, I recommend not just putting the code chunks in here, but I have these additional comments, and if they apply to you, I would put those in here. And one comment I'll make is that you can see how height underscore inches is in a bit of a gray box, and it is in a fixed width font. Same thing with height in feet and height inches over here. I do that with a single left tick. So in the top left corner of your keyboard under your escape key, I'm adding those left tick marks, and that changes the color in RStudio, and it will appear now in a fixed width font. I believe that that's helpful because it helps you distinguish where a variable name is from the description around the variable name. To that end, I'm going to go up and I'm going to steal the writing I did for this smoking categorical variable. Okay, so skip ahead 30 seconds if you don't want to watch me put left ticks in. Okay, I'm done putting those left ticks are in, and let's see what the next thing is that we're going to do. So we've got numeric to numeric. You can do all sorts of things here. You can do logarithms, anything. We're going to do logarithms a little bit later in the semester. Oh, in fact, we're going to do it imminently. All right, the next variable I've got is total cigarettes smoked. So daily cigarettes smoked and days smoked. Do I have both of those variables created? Let me go remind myself. So I've got days smoked. I just created that one. And then I need to remind myself daily cigarettes smoked is a variable from my original code book, which is a number of cigarettes. So if I know, the usual quantity when a person smokes cigarettes and how frequently they smoke, if I multiply those two together, I get the number of cigarettes that they smoke every month. Every month only because that's the units that I used for my days smoke variable. Right. Okay, so I'm scrolling down again. Numeric to numeric. All right, so here is what I'm doing. The variable total cigs smoked, and that's doing this again. I would probably append an underscore MO to this variable to indicate that this is per month. But this is the total cigarettes smoked per month by multiplying the days smoked and the daily cigarettes smoked. All right, so let me grab this text, go to RStudio, go down to the numeric from numeric, paste this text in here. And create a new code chunk where we insert this mutation. All right, so we're starting with the NESARC data subset. We're mutating to create a new variable called total cigarettes smoked, which equals the product of days smoked and daily cig smoked. And we should really have a summary of that. Let's have a summary of that. So I'm going to grab code that I wrote before and just replace this with total capital T. All right, and I'll run this code chunk, no errors, and the average number of cigarettes smoked per month is 187, with a maximum of almost 3,000 cigarettes smoked. Okay, that's 100 cigarettes per day. Very good. We have a log scale here I believe, let's make a quick histogram of this new variable. You can see how right skewed it is over here. I'll make a few more bins. Okay. So lots of people smoke very little, but then there's a few people who smoke a lot. So I have put in a log scale. You know what? I think this is something that we can do later. Let's not worry about log scale for now. We'll come back and do that when we do the logarithm section. All right. What if we want to create a numeric, start with a numeric variable and go to categories? Now there's lots of ways of doing this. I will show you a way to do it that is not shown right here in a moment, but let's start here. So one way to break up a numeric variable by categories is by quantiles. You can say, I want 4 equal categories. So the first 25% of the data, the smallest 25% of observations, the next 25%, the next larger 25%, and then finally the largest 25% of the data. So that's one strategy. Another one is you can define those ranges by yourself. And in fact, let's do that instead of doing this quantile thing. The quantile strategy is a little bit lazy, quite honestly. All right. I think I need to use this variable because I might use it later. Let me do a couple things. Smoked fac. Let's see how many times I use this. I see that there's 17 uses of it. And let's just see. So there is a one use of it. It appears in summaries. Do I ever use it in a plot? Here I use it in a plot, but that's just that's a really dumb plot. Here I use it in a table. So I never use it for an important analysis. So we can do something different with it. All right. So I'm going to start, you know what? I'm going to start with this case when, because that is really the best way to go. I'm going to use the one that we used before. Days smoked. Okay. All right. Hang in there with me for a second. We're going to go from a numeric variable to a categorical variable, and we're going to define, oops, I didn't create my code chunk first. And we're going to define categories based on sort of reasonable ranges of the data. So let's find, so the variable I'm going to create is SIG's smoked factor. So I'm going to put, right, so I'm starting with the Nisark subset, and then I'm going to mutate, I'm going to create this cigarette smoked factor variable, FAC, and then the variable that I care about is total cigarettes smoked. Okay, so that's something I'm going to put in here, and I'm going to do a little bit of cleanup to get started. Okay, so first thing we need to do is understand a bit about this variable. So let's start by looking at a summary of that variable. I'm going to just put my cursor on this line, press Control Enter. It will submit it to the console and it will give me the 5-number summary and the mean. So it looks like, I mean, that's the same total sig smoked. That's the same as this histogram over here. So it looks like, almost there's tons of zeros, and then there's this right tail. So how would I want to break this up into, say, 4 categories? So like no smoking, low, medium, and high smoking. And this is going to be fairly arbitrary. Let me go over and look at my okay, I didn't get any information really. So if cigarettes smoked equals 0, then we'll say no smoking. Okay. Now I'm going to copy this line, basically give myself sort of a bit of a template. Well, I'm going to do that on the next set. Okay, so if cigarette smoked is greater than 0, I'm going to wrap that in parentheses. This is not strictly, you don't strictly need to do this, but I always wrap it in parentheses so that it's easier for me to keep track of what's happening. Okay, so and I'm going to basically have two conditions, right? So if you're greater than 0 and you're less than or equal to some number, and we need to choose sort of an arbitrary a number here. Let's get a sense of what if we create a table of these numeric values. Let's learn a little bit more about this. So those who answered 0, there were 25,000 of those. Then 356 answered 1, etc. Okay, so where do we think a good cutoff would be? It looks like, I don't know. So let's see. Maybe context would help us. So if a person smoked once a week, like say they only smoke when they go out, when they go to parties or something, then in a month you'd expect them to smoke 4, like if they smoked 1 cigarette each time, maybe they'd smoke 4 or 5 times. So let's see, there is sort of a natural stoppage around, like you can see a high frequency at 5, a high frequency at 6, and then it sort of gets low. So maybe all of these people from 1 to 6 are the weekend smokers. Okay, so let's do that sort of 6, and so this is sort of like they smoke about once a week. So what should we call this? Maybe we'll just call it low smoking. And maybe I'll add 6 or fewer as part of that label, so that we understand what that category, what low actually means. All right, so now I'm going to take this, I'm going to copy and paste it a few times. I'm going to add some commas. And now we can define our other categories. I don't know exactly how many categories we want, but I'm going to show you one more trick for this. Okay, I'll come back to that in a moment. So if we ended at 6 over here, so now we're going to say greater than 6, and we'll do medium smoking, and then high smoking. I guess those are the only categories that we want, really. Yeah, I'm gonna get rid of that. Okay, I'll tell you what this does, and then but we're not going to use it for this case. Everyone else. All right, let's go define a few more categories. So if you're above 6, so you're 7 and more. I don't know. So contextually, all right, 6, 20. If you got up to 30, 30 is someone who smokes 1 per day. So maybe we can go up to 30 and less. Okay, so maybe we'll do 1 to 6. This maybe makes more sense. 7 to 30. We just define those ranges. So greater than 6 up to 30. Let's put the spaces in a better place. We'll put them before the 6. And we'll put some extra spaces over here. And then we've got 31 up to, let's see, that's 1 cigarette per day is 30. 30 is right here. And then we've got people who do 2 cigarettes a day. That's 60. What would we consider high smoking? If 300 is 10 cigarettes per day. Let's see, maybe low, medium, and high are not enough categories. Let's do 300, so that's 10 cigarettes a day. And then we sort of have extreme smoking after that. Okay, from a pedagogical point of view, you can see why this is important to plan your lectures before giving them. All right, so what do we, let's see, medium and high, low. Okay, maybe we'll do weekend. How about single? I need more terms rather than medium, low, medium, and high. What are more terms for that? Low, medium, high, scale. Oh, moderate. Speedometer. Don't we have any nuance? Fairly high, moderately high. We can only modify low, medium, and high. Come on, guys. Hasn't the universe solved this problem? Okay, that's what I'm going to do. We've got no smoking. I'm going to move this over. Okay, autocomplete is the thing I hate most in RStudio, because I know what I want to type. Okay, cigarette smoke 0 is no smoking. 0 to 6, lowest smoking. Greater than 6 to 30, low smoking. 30 to 300, medium smoking, and high smoking is going to be 300 or more than 300, 300 and more, 301 and more. All right. So the way this case when statement works is it goes through each of these cases, each of these situations, and the first one it finds that satisfies the condition, it applies that label or that value to the new variable, and it goes on to the next row in the data set, and it iterates through. So that means that, you know, if 0 is encountered, we get no smoking, etc. We go through all of these, and finally, anything beyond that didn't meet any of these is this next statement. And this next statement is always true. Therefore, if it didn't meet any of these previous cases, it must go into this last one. Now, of course, this can have unintended consequences. It shouldn't in this case, but one example would be, what about negative numbers? Right? If you didn't think ahead about negative numbers, then this would represent negative numbers too, because we only have 0 and positive numbers up to 300 defined in these first 4 cases. Okay. Anyway, so this is a nice way to do this. Let's see what the result is. We'll create the new variable down here, and we'll do a summary of it after it's created. We'll run this code. Nice. So we have a character variable, which we now need to turn into a factor variable. So let's do that. There's a few places we can do that. I will probably just show you a fairly simple way of doing that. So we create the cigarette smoked factor variable, and now we're going to turn that into a factor. I think, let's see, this may by default sort these categories alphabetically, which is not a very meaningful way of defining them. So we can look at our factor variable, the code that we used when we created factor variables. So renaming variables, coding missing values, replacing, so missing values, replacing 99s, creating new variables. I see. Is it below that? Okay, finally. I apologize. It was down a little bit lower. So we want to do something like this, where we specify, let's see, labels. All right, the reason I'm pausing is because factor variables can be a little tricky. We actually don't have numbers right now. We actually define these specifically with their labels. So the way we can do this is we're going to create a factor variable with this variable, and the levels are going to be equal to this list of labels. So I'm going to copy those, and I'm going to make a copy down here, and I'm going to delete all the stuff we don't need. Okay, now we just have the labels, and can I do that? Yeah. Okay, so we can put in those levels. Here. Okay. So cigarette smoked is a factor variable. We start with the cigarette smoked variable. We apply the levels argument, and we give it those levels, and then we close the parenthesis on the factor variable, and we're done. All right, so I think this will work. Let's take a look. I'm going to run this chunk of code, and now when we do our summary, we have our categories. Excellent. If similar to summary, if we were to create a table, it should basically look the same. Yes. Excellent. Okay, so I feel pretty good about this. These numbers visually feel, at least to my memory of the table that we created before, seem about right. And if we add up all these numbers in the table, we should get the total sample size of the data set, and we do. So everyone shows up here. I made an error. Did you catch it? So there are NAs, I believe, for the cigarette smoked. Let's go check on that in a second. Cigarette smoked, total cigarette smoked. Sorry guys, this is a mess. All right, here we go. Total cigarettes smoked. There's 297 NAs. Where did those 297 people end up? They ended up in the high smoking group. Why did they end up there? Because everyone else was put into the high smoking group. Okay, so I do not want to do a true here. I want to do one of these statements that says if you're more than 300, then you're in the high smoking group. We want those NAs to stay as NAs. Okay, so let's review the numbers that we have down here. Okay, they'll hang out. And we will run this piece of code above and then make a comparison. Okay, in particular, we care about this last group, 9086. Oops, so I need to scroll up a little bit here. Aha, 9383. I caught a mistake. Okay, I would have had those almost 300 people with NAs end up in the high smoking group, but now they are still NAs. And in fact, we see the summary for the smoking factor has an NA group, whereas previously, when I had made a mistake, there was no NAs. Okay, so that is the danger. And I did point out the danger before of using trues there. I pointed out in terms of negative values, but of course it applies to NAs, or missing values, as well. All right, so we've successfully created a categorical variable from a numeric. Let's see if there are any more cases to be interested in. Yes, there is. Okay, so the next case is from many categories to a few. Okay, so I have a case where we don't have too many categories, but some of you will have many categories, and will really want to take advantage of this option. Okay, so I've got a smoking frequency 3 variable, which I'm going to create to have only 3 variables from the 6 variables that are in my original smoking frequency variable. Okay, so let's add a code chunk in here, and we'll paste. Okay, so first thing I do is start with a table for the variable that I'm going to be using. Let's take a look at that table right now. Okay, I've got 1 through 7, where 7 is the no smoking group. Okay. Next, there is a function inside the package for cats, F-O-R-C-A-T-S, means for categorical variables, where we can collapse categories. Okay, let's make this window larger. Okay, and here we are. So we already looked at the table of the original variables. Now in our data set right now, we haven't labeled these categorical variables yet in the code because it happens later in the code. We did label the variables, but those lines of code have not been executed yet. So we're looking at these numeric variables. In fact, let's take a very quick look at the structure of this variable. It is a factor with those levels. Anyway, I think the values here, okay, that's the purpose of, I apologize guys. Okay, so factors, as you recall from the lecture videos and the notes, the factors are represented in 2 ways. They're represented as their labels, which are the names that we give to them. For example, in what we just worked on, these are the labels. In fact, we just created this cigarette smoked factor variable. Let's just take a look at that cigs smoked factor variable. There are levels, which are the okay, well, there's a couple things here. So levels are those names. Oh, interesting. Labels. Oh, that doesn't work out. As numeric. Okay. levels, and as numeric. Okay. Trying to get enough on the screen that I can show you what I'm talking about. All right, so the levels, this doesn't quite make the point that I want to make. So within R, factor variables are stored in two different ways. One is by a numeric code, 1 through 5 in this case, and they're labels, okay? And the labels are the meaningful label to a fairly arbitrary number. And so you can define, you can work with factor variables with either the numeric or the categorical or text version of the variable. In fact, so this as numeric, look what happens if I do as character. It puts in the character label. And so you can take a factor variable and look at the numeric value, or you can use the character string. All right, for our current data, where we're doing many categories to a few, and we're looking at this smoking frequency variable, it only has the numeric level from the codebook because we haven't yet created it as a factor variable and assigned it a level. So if we look at this as numeric, we'll just have the numbers 1 through 7. Or if we do as character, we also have 1 through 7. But because it's a character string, it's putting quotes to indicate that it's not a number, but it's the character version of the number. It could just as well be the letter A. Okay, so in creating this new variable, you can use either one. They happen in this case to be the same, the numeric and the version and the character version. All that to say is that be careful with using functions like this and how you refer to levels of a factor. You can see in quotes, I'm referring to this as the character version, and that works just fine. Okay, so all of that, let's take a look at this smoking frequency variable in the code book. Here it is, smoking frequency, it's already highlighted. I've decided to take these 6 categories, 1 through 6, and collapse those to basically like once a week, once a month, and so on. And so the levels 1, 2, 3 are all sort of smoking roughly weekly, right? From as few times as 3 times a week up to every day. So I'm creating a new variable called smoking frequency. Let's start at the beginning. I've got the Nisark subset, and then I'm going to mutate to create a new variable called smoking frequency, which will equal the collapsed version of a factor variable. We're starting with the variable that we already have in our data set, smoking frequency, and whenever the smoking frequency variable is one of these values, 1, 2, or 3, then we will assign a 1 to smoking frequency 3. And therefore we've collapsed the original categories 1, 2, and 3 from smoking frequency to the single value 1 in our new variable smoking frequency 3. Then we've got these next 2 levels, 5 and 6. Let's go take a peek. 5 and 6 are 1 to 2 times a week to 2 or 3 times a month. And so I've decided to call that weekly. So if you're 4 or 5, then I'm putting you into a category of 2. Otherwise, a 6 is once a month or less. We'll call that 6. We'll put it into its own category of 3, and that's monthly. And then 7 is a level that we defined earlier, which is never. And we'll put that into its own category as well. All right, so let's take a look at the result of this. We'll run this. Okay, and two pieces of good information came up here. First, we made a table of the original 7 levels, and that gives us something to compare with, right? So we collapsed levels 1, 2, and 3 together, and so that means if we add these 3 numbers up, having trouble highlighting them, these three values up, we should get about 16,000. So we start with 14,800 and we add to that 1,100. Yeah, about 16,000. That makes sense to me. The second category was when we combined levels 4 and 5, and that gives us 1156. That looks right. 6 became 3 and 7 became 4. Perfect. I'm very happy with the result here. And so for you, say you had the country of origin in your data set. Let's see if we can find that very, very quickly. It's hesitating. Country? No. Origin. Here we go. Origin or descent. Okay, so this is a variable that's got 31. Does it continue? Yes. Okay. Has 58 labeled categories. So that is not you're not going to be able to really do any statistical analysis with something with so many categories. So here's one where I would use all the labels, copy and paste this, put quote signs, beginning and ending for all these, and then find sensible ways of grouping them into, maybe as many as 5 or 6 at the most origins. Maybe think of it in terms of either continents or choose a reasonable way of handling that. All right, let's see if there are any other things here. I apologize for this long video. All right, review the results of the new variables. So if we just look at, so here head gives us the first, in this case I've specified the first 10 observations, and I'm looking through to see that, for example, we've got so height in feet and height in inches. The new variables we created are going to be at the end. So here's the height in inches total, and so we've got 5'7" equals 67. Looks right to me. 5'1" is 61. Good. So looks correct, and that's sort of one quick way of getting a sense of whether what we did is correct or not. So I'm pretty happy with what we've done. We've done a lot of work. If I was you, as I was going, probably after each step, I would have knit the document to make sure it still works. I've done this enough that I'm feeling pretty confident. Okay, I'm going to skip over dates today, and we can put in a summary here of the whole data set, maybe. Summary nisarc._sub. Okay, there's a smoking frequency 3 variable. There's the cigarette smoked factor variable. So things are looking pretty good. Let's knit this, look at the result, and wrap up this video. So the benefit of having gone through this is that there were questions that we couldn't ask or couldn't answer without having created these additional variables. Let's see, this is our current assignment, and let me just go up to the table of contents and find creating new variables. Okay, and all this output looks pretty good. The main thing I want to look at is the the summary. So for the variables we created, we've got height in inches. That looks good. Total cigarettes smoked is our numeric variable. We still have those NAs, which is good. The smoked factor variable, we still have those 300 NAs. That's good. And smoking frequency came from this smoking frequency up here. And you know what? Smoking frequency 3, right? We created this new categorical variable, but we haven't labeled it. So that is the last step to do. So I'm going to copy this for myself. I know that the variable name can be found. My computer's hesitating. Okay, and I'm just going to go find the code that labels that factor variable. Okay, so if you've created new factor variables, you want to put that in the same section where you label all your other factor variables. So here is the labeling categorical variable levels. We created some new variables. I'm going to put this sort of sequentially at the bottom of all my labeling. And so there is I'm starting with the smoking frequency 3, defining the 4 levels, 1, 2, 3, and 4, and giving it those 4 labels. And is this the order that I want to go in? It's probably fine. Let's see, I think I did the orders for the other ones in the reverse order. Let's just go double check. I think I did none as the first. Yeah, so here, smoking frequency, I had never was first, and every day was last. Let's put this one in the same order. Okay, so I'm going to define the levels as 4, 3, 2, 1, and I'm going to swap around these labels there. Okay, so now we've got them in the same order where never is the first category. Good. Let's knit this again. We'll look again at that summary. Coding is a lot about making a small step and checking your work and then fixing the thing that you didn't quite get right. Okay, so I'm going to refresh. Oops, I need to refresh this one. Let's see. Good. So we created that, and then at the end of the data summary section, we have a section where we look at numerical summaries to assess correctness. And one of the last ones, smoking frequency, never is the first category. Nice. Those are the labels that we just added. Perfect. So I'm very happy with what we've done here today. I'm not thrilled at how I did it, but I am happy with what we did. It took a while, and that's how you can also create new variables for your data set. All right, in the next 2 videos, we will be plotting variables, possibly some of the ones that we just created, in relation to other variables, bivariate relationships.